Good evening friends. Now let us see the structural RCC utilities in the line and space add-on which works with BricsCAD, and it is very useful for structural engineers. Let us see how it works. First of all, let us open the toolbar which is available in the RCC in the line and space toolbars submenu. Right now you can see the footing details. These footings are drawn using the draw footing icon, draw footing command. Click it, and here this is a bare drawing. In this we have selected the column, and here we have to type the size of the footing. It is 6 feet. By default it is 6 feet. You can press enter. 6 feet along the y-axis also it is 6 feet. And you can name the footing C1 by F1 or whatever. If you want to change the name of it, you can change the name. And you want a simple footing or detailed footing. So if you want a detailed footing, you just type B and enter. So it has drawn the footing. Again, let us draw the beam section. For drawing the beam sections, you can see the typical beam sections I have drawn here. So these I will show how to draw. This is the command for drawing the beam sections. So this is simply supported. Let us take a beam which is simply supported. So I am taking a simple beam because if it is a complicated one, it will be cumbersome to understand. This is a simply supported beam. Left support I have selected. These are the right supports. Here everything is a pick right support points. You can pick the right support points. This is the only beam which is available. This is the simply supported beam. You can type the name of the beam. If it is SB1, SB2, whatever it may be. The beam name you can change here. You can change the beam width and beam depth also, and slab thickness of the beam. If it is the RCC beam, if it is a slab beam, you can add slab thickness. If it is a plinth beam, you can make it 0. So in the beam, top bars, bottom bars, left extra bars, top right extra bars, bottom right extra bars, you can edit them. If you want to make them 16 or 16. This is not a structural software. It is only a drafting software. So you must not rely on what it says. You must edit it. So whatever it says is just for drafting purposes. So you must take care that the steel is correct. So after drafting, you can draw it. Draw. It will draw. It has drawn it here. SB2. The beam. Suppose these are, again I will draw once more. Simply supported. So 1, 2. These are the left support points. These are the right support points. And suppose this support is not supported by column. This is supported by beam. You can edit the supports also. The left side support is not a continuous column. It is supported by beam. And right support is also, it is not a continuous column. It is supported by beam. Okay. Now you can edit the name of it SB2. Remaining all are same. You can just draw it again. So the supports are supported, they are turned into beams. They are not supported by columns. So we can change that also like this. And then we can add the slab steel. For drawing the slab steel, we have to select two diagonally opposite corners. I have selected the left corner and I am selecting the right corner. In this we can edit what is the main steel, what is the distribution steel. It is only indicative. If you want to change, we can change it. 8 mm or whatever it may be, we can change. If you want cranks, then you must turn it on. Otherwise, we can remove it also. But it's a two-way slab. Then, if you draw it, it will draw it. Steel. Next, staircase. If you want to draw the staircase section, staircase steel, it is just starting point of the staircase, ending point of the staircase. So it has drawn the staircase steel. By default, it will draw like this. We have to do small editing. We have to do some trimming and editing is there, because it will do the donkey work. Donkey labor will be completed. It will do all this. Remaining, we have to do some editing. Likewise, we can calculate the beam quantity, beam steel quantity. I have prepared the beams for all the slabs which are there in this left side drawing, and we can calculate the steel required just by selecting, and it will calculate. We have to type how much extra percentage we want. 10% extra for 8 mm rods, 10% for 12 mm rods, 16 also 10% extra, or you can make it 0 also. Then it will write. It has written there. this total rods and all this 589 kgs of beam steel is required. Again we have to calculate the steel for slab also. Then we can add both of them. This is the beam steel. Here we can calculate the footing steel quantity also. Here we can add footing, or we can see footings zoom. Let us see how. Suppose there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 columns are there. So in this, suppose if all beams, suppose 6 beams are 6 by 6, 6 footings are 6 by 6, and 6 footings are 5 by 5. Let us see. Footing width 6 feet by 6 feet. The main steel and distribution, if it is 10 by 10, suppose. Number of footings are 6. We can add one more footing, which is only 5 feet. 60, 60. And it is also 10 mm by 10 mm. Then you can just calculate the steel and you can write the footing steel. 10 mm extra. 10 per, it will write footing steel is required. How much footing steel is required for this? Footing steel, beam steel. You can calculate slab steel also. For slab steel, we have to select one corner to another corner. Main steel dia 8 mm, it's 8 mm, 6 inches center to center is there. 8 mm, 6 inches center to center, and distribution 8 mm at 8 inches. 8 mm dia 8 inches. Likewise, we have to select. We will go on selecting. So after completion of it, you press enter. It will ask for any extra percentage wastage is required. If you add 10% extra, it will add whatever you suggest extra, and it will give us the slab steel quantity. Likewise, you can calculate the column steel quantity also. Column steels. Suppose there are 12 columns are there. 6 columns of this type, 6 columns of this type. You can select this. This is the first column, and the number of columns are 6. Here we have to read everything. Here enter the number of columns. 6. Height of the columns is 10 feet. Okay. Now overlap length. If you want to add the overlap length, press enter Y. Otherwise, enter N. Let us add the overlap length. Now again, let us add this. This is one more. These are 6 columns. 6 more columns. Height of the column is 10 feet. Overlap length, yes. There are no more columns. If you want to add any extra steel, you should press extra percentage, 10%, or you can press just like 0%. It has written here. Column steel, 8 mm this many rods, 16 mm this many rods, totally this many rods. Likewise, we can calculate all the structural steel structural drawings. I have prepared all this to simplify the work of civil engineers.